All right, this is honors pre-calculus. This is the graphs of tangent, cotangent, cosecant, and secant functions. Let's get started with the tangent. All right, so first of all, if you guys look at the positive sign, there's not going to be any reflection, okay? But if you see a negative, that's the one you have to reflect over x-axis, okay? So which means that over x-axis, you're going to see a curve in opposite quadrant. So this part is going to reflect it over to the quadrant 4, and then from quadrant 3 is going to reflect it over to quadrant 2. Okay, so let's look at the a value. So a value is going to determine, you're not going to have amplitude in this case, so you're going to have it steeper or flatter. Okay, so if it's steeper, it's going to look like this. See, the curve is going to be steeper. If it's flatter, then you're going to see getting a little chubbier. Okay, the curve is going to be a little chubbier. All right, so let's look at the b value. So b value, this is determining the period. Instead of using 2 pi like sine and cosine, for tangent you're going to use pi. Okay, pi over whatever the b value is. In default, b value, if it's 1, then pi over 1 is going to be pi. So your period is going to be pi in this case, and then you got to understand that for tangent graphs, it's going to be within negative pi over 2 and pi over 2. Okay, so it's going to be equal distance to the 0, 0. Now let's look at the k. This is going to be a translation, either going up or down. Okay, if it's positive, it's going up. If it's negative, it's going to go down. So the whole entire curve is going to get shift up or down. Now let's look at this. First thing you should do is to label the period. So b value equals to 1. So you have pi over 1. So your period is going to be pi. Okay, so you want to make it equal to the to midpoint. I mean to 0, 0. So you're going to say it's pi over 2, and then this side is going to be negative pi over 2. Okay, I already grabbed the parent function, so call it, and I'm going to show you guys the reflection. Okay, so there's going to be a reflection over x-axis. So from quadrant 1, it's going to reflect it over to quadrant 4, and then from quadrant 3, it's going to reflect it to quadrant 2. Now I'm going to have to make, because the a value is 2, so it's going to become steeper. Okay, so you're going to have to go from the reflective image and make it steeper. Okay, so the red curve is going to be your answer. This is your y. I mean your function. Okay, so let's look at the next one. Looks like there's not going to be any reflection going on, and there's not going to be any steeper. So all you need to do here is to determine the period. So it's going to be pi over 1/2. So your period is going to be 2 pi. So you know the whole entire period is 2 pi, and then make it half for each negative. So make it negative pi, and then make this pi. Okay, and your answer is just going to be this curve right here. Okay, let's look at the next one. So this one is going to be a little bit more complicated. You can just analyze it and see there is no reflection going on, right? But this one is going to make it flatter. So I'll put FL for flatter. So making it flatter. Okay, now let's determine what the period is. So it's going to be pi over 1/4. So it's going to be 4 pi. So the whole thing is going to be 4 pi. So make it 2 pi over here, and then negative 2 pi over here. Okay, and then just focus on the red one. So now we're going to shift down by 2 units. So you just go 1, 2, down 2. And then just draw a curve that's looking kind of like the red curve. All right, that's it for the tangent. Take a little break. All right, so this time we're going to be talking about cotangent. It basically is the same thing, okay? The reflection is when you see the negative for the leading coefficient, so there's going to be a reflection over x-axis, okay? A is the same thing, either making it steeper or flatter, okay? Cotangent, it's going to be a little different. First of all, we know the b value is determining the pi, okay? But this time you're gonna have to use pi over b. Well, it's the same thing as tangent, right? But look at the interval that my period is. My period is gonna go from 0 to pi, okay? All right, so next thing I want to do is determining is there a vertical or vertical translation. So it's the same thing as tangent. So if it's up, it's positive, and then if it's negative, it's going to go down. So let's get started. Okay, so first of all, however you want to start, we can start with the period. So b value is 1. Okay, so pi over 1 is going to be pi. So you know that your period is going to be just pi. Okay, so you start from 0 and then end it with pi. Okay, all right, so let's look at the reflection. So the reflection is going to be over x-axis. Okay, so this is how your curve is going to look like. And then the 3 is going to make it steeper. Okay, so you want to draw a steeper curve like this. So the red curve is going to be your y, your function. All right, so for this cotangent, let's look at the period first. Okay, so you want to use pi over 4. Okay, so your period is going to be 4. Okay, so you go from 0 to 4. Okay, looks like that's all you need to do because there's no reflection and there's no steeper or flatter. So just keep it the same as the one that I start up with. All right, so for this next one on number 34, I purposely put a negative in front so you can see a reflection going on. So this one gives you a reflection over x-axis. Okay, so it's gonna look like this. Okay, let's look at the steepness. Sorry, so it's gonna be steeper. So you're gonna look a little steeper than the purple curve. Okay, let's determine the period. So b value is 1, so pi over 1 is just pi. So it's just gonna start from 0 and then with pi. And the whole thing got shifted down. Oops. The whole thing will be shifted down by 1 unit. Okay, so you're gonna go right down 1. The whole thing gets shifted down by 1 unit. Oops. Okay, so it should be steeper, right? So something steep. All right, so the purple one is the answer. Okay, so that's it for the cotangent. Okay, take a little break. And then now we're going to do the cosecant. So cosecant, look at this crazy stuff. Okay, so I'm gonna show you guys what to do with the cosecant. You start from the understand that cosecant is the reciprocal of sine. Okay, so what you need to do first is whenever you draw the cosecant, you're going to be starting with drawing a sine graph. Okay, a graph for a sine function. Okay, and then you're going to do all the things you could do, and then in the end, you just go ahead and put 2 u's. One is the regular u, another one upside down u on the tip, or I call it the local maximum and the local minimum of the sine graph. Okay, understand that everything is basically the same and then all you need to do is just draw those two little parabolas, and that's it. Okay. There is an asymptote here. So the asymptote is where the sine graph equals when x equals to 0. Okay, so technically you're gonna have another asymptote here. You're gonna have another asymptote here. Okay, so it's gonna be 3 asymptotes for every period. So you're gonna have to use the knowledge that we have done for the sine graph for cosecant. Okay, you start with the analyzing what the amplitude is. So a value is 1. So you're gonna mark 1 and -1. Okay, so look at the period. So that's gonna be 2 pi over 3 pi over 2. Okay, so that's going to be 2 pi multiplied by 2 over 3 pi. Okay, so it's going to be 4/3. Okay, so in this case, your period is going to be 4/3. So you're going to put 4 over 3. Okay, that's not going to change the fact that I'm going to always ask you guys to mark the midway. Okay, so you're gonna say that this one is 2/3. Okay, everything you're just gonna keep it the same. So this is gonna be a sine graph. Okay, so cosecant, all you need to do is understand there is gonna be an asymptote here, and there is gonna be asymptote here, and there's gonna be asymptote here, but then you're just gonna go ahead and draw the parabola. Okay, it should be attached to the sine graph. Okay, 2 parabolas like this, and that's it. All right, so number 30. So this time I'm just jumping around, showing you guys different questions. So first of all, we can determine the period. So it's gonna be 2 pi over 2. So the period is gonna be 1 pi. Okay, halfway is gonna be pi over 2. Okay, look at the 1/2. That's the amplitude. Okay, so 1/2 and then -1/2. And then I'll show you in the green curve, that's the sine for that's a sine function, graph for the sine function. And then go ahead and just, let me use different color here. Go ahead and just draw 2 parabolas. One going up, one is opening down. That's all you need to do. All right, so this time we have amplitude is 2. So you start with the 2 and then put -2. For the period, we know the b value is 1/3, so 2 pi over 1/3, it's going to be 6 pi. Okay, so it's going to be 6 pi, and then the halfway is going to be 3 pi. And then there's going to be a translation going down by 1 unit. Okay, so you're going to go down by 1 unit, knowing that you start from 0, 0. So down 1, so it's going to be starting from -1. The highest was 2, now the highest is going to be 1. The lowest was -2, so the lowest now is going to be -3. So everything just got shifted down by 1 unit. Okay, so this is how your new sine curve is going to look like. It's going to look something like this. Okay, something like that. All right, and then all you need to do afterwards is just go ahead and draw the parabolas. That's all. Okay, so that's it for the cosecant. Okay, take a little break. Now we are going to work on the secant. So secant is basically the reciprocal of cosine. Okay, so everything is the same. Like, you're gonna have to start with the cosine graph, and then you're gonna be working on drawing these curves. Okay, keep in mind that for this first part and this last part, it's like half of the parabola. Okay, only the one in the middle is gonna be a complete upside down parabola. All right, so secant, let's start with the first one. So you know the amplitude is going to be 2, so you start with 2 and then down -2. Okay, all right, so the b value is 1, okay, so you use 2 pi over 1, it's going to be 2 pi. So that's going to be your period. And then I already show you guys the cosine, right? And then you just go ahead and draw the half of the curve for the first part and the complete upside down parabola, and then the half of the parabola on the last part. And that's going to be your secant. Okay, so let's look at 32. So there's going to be a reflection going on. But let's mark down the period first. Okay, so we have 2 pi over 2. So that's going to be 4. So you have 4 as your period. Halfway is going to be 2. All right, so the amplitude is going to be 3. So it's going to be 3 and negative 3. And then look at the reflection. It's going to be over the x-axis. Okay, you can even think of it that because the leading coefficient is negative 3, you're going to start from negative 3. Okay, so your cosine is going to look like this. Okay, and then just work on those parabolas. Like, see, the first part is going to be half of the parabola, and then the middle is going to be, now because it's a reflection, so it's going to be the just a regular parabola opening upward. Okay, and the last part like that. All right, so let's look at the last question. So this time it's going to be a little bit more complicated. Just start marking the period, amplitude. So 2 pi over 1/4 is going to be 8 pi. Okay, so the period is going to be 8 pi. Halfway is going to be 4 pi. And then the amplitude is 3, so it's going to be 3, and then lowest is going to be negative 3. So the purple curve I'm showing you guys here is that we know we have to move up by 1 unit. So see, everything gotta get moved up by 1 unit. Okay, I started from it will go through the 0. Now it's gonna go up by 1 unit. Okay, so your cosine is gonna look something like this. Okay, after you worked on that, you can just go ahead and do the the secant. So it's gonna go half of the parabola, and then a parabola downward, opening downward. Okay, so that's it for the lesson 6.5. Take care.